Hello, in this video I'm going to present to you a progress overview of my license project for my bachelor's in computational physics. This application opens Gaussian files and extracts molecule data from them. The application is still heavily under development, so you might see some bugs here and there and other things that are not fully implemented or not implemented at all. That's why I'm still running it in Visual Studio in debug. So let's get started. Upon opening the application, this is what we see. This is what the interface looks like, and this is acts just like a normal Windows window, and you can minimize, maximize, scale it. In the interface we have an item explorer, an inspector, and a main display. And right now, because we have no file opened, the main display prompts us to open a file, and we can do that either by clicking on this little button or going to File, Open, or just pressing the hotkey Control O. So I'm gonna click on that, and this little window pops up, and it works just like a file explorer, a Windows file explorer. So I'm going to browse to where my files are. Here are all of them, and I'm just going to select all and open. And as you can see, it splits the file into jobs. And right now it recognizes only 4 types of jobs, which are the most interesting, like the optimization, frequency, NMR, and TD. I also have a formaldehyde energy calculation right here, and it says unknown. And that's because in an energy calculation there's not really anything interesting to look at. And that's why if we have some sort of job that is not within these 4 categories, the application just says, okay, this is an unknown job. So clicking on it, on an item in the Explorer, updates the inspector, except when we click on this unknown file, then there's nothing to show. So going through them one by one, we have a content tab button, which just shows you the content within the job file. And this is just a bunch of text. This particular file, APA OF NMR, is I think 6,000 lines long, and this underscore OPT is about 2,000 something lines long. So there's a bunch of data in here. We can also save it as a standalone job if we want to, if we need it. And below that we have this orientation expander, and by default it is selected. The input radio button is selected, and clicking on this button right here opens up the orientation tab. And for this particular item in the Explorer is just a water molecule. There's nothing really interesting, just 3 atoms, 1 oxygen, 2 hydrogen. And it shows you this data right here, which is, these are just indexes, atomic numbers. This is irrelevant, and these are the Cartesian coordinates in an XYZ coordinate system. But if I click on this, which is another optimization job, the inspector stays completely the same, except when I click this orientation button again, it updates the data in the inspector. So now, right now, the inspector has 1 job file selected. I mean, the item explorer does, but the inspector looks through the data of the selected item, if that makes sense. And for this particular one, we have 11 atoms, atomic numbers, and their coordinates. If I click on standard and select standard, and I click new orientation, it says standard orientation, and I'm not sure if you can see, but the coordinate data updates. So input is the molecule as you fed it to Gaussian for calculation, and standard is data after Gaussian has run the optimization calculation. And we can also save it as a txt, and it says standard orientation.txt. Or if I select input and save, input orientation.txt. Okay, beneath that we have a 3D structure expander and this 3D viewer button, and just opens up a new window that again works just the same as a Windows window, and it allows you to view the molecule in 3D. And here we can do some nifty little things like a standard 3D viewer where you can click and drag and rotate the object around. You can zoom in or out, and you can pan if you want to. On the right we have this panel which we can collapse or expand, and we can also drag to scale it. And right at the top we have properties, and these properties are for the selected atom. So if we click on an atom, we have it tells you what atom it is. So these are both hydrogen, and I believe the one in the back also. This one is, I think, carbon. Yes, it's a carbon atom. It tells you the atomic number, the center number, which is the index of the atom in this configuration, and it also tells you the position of where the atom is placed in 3D space. Below that we have this animation expander, which right now, because we opened an optimization job, it doesn't have any vibration data, so the animation expander is disabled. Beneath that we have the viewport, some viewport option, and what you can do here is change the background color if you want to, and I'm going to show you in a minute why that is. You can also toggle this transform gizmo if it annoys you, and you can also toggle the Cartesian axis if you want to see how the molecule is oriented in 3D space. So X red, Y green, and Z is blue. So that's it for an optimization 3D viewer. Moving on to a frequency tab, we have the same thing, and this content and save content, this is the same for all types of jobs, so for all 4 of them. So I'm not going to go through it again, but for this frequency job we have a frequency data, and this is the data exactly as it appears in the Gaussian output file. So the same layout, same everything. You can also save it as a TXT if you need it. Below that we have vibration modes, and this little label tells you there are 27 vibration modes in total. So if I were to go to biphenyl, which is another frequency job, it should, it doesn't really update. Yeah, so this is a bug. It should update the inspector. So this one has 27 vibration modes, and if I were to click on biphenyl, it should update. Okay, so we have 60 vibration modes, and by default the selected vibration mode is 1. I don't know if I mentioned, but these panels are all scalable, and the UI updates accordingly. So as I was saying, the selected vibration mode by default is 1, and you can open up a new tab, and it shows you all the data for that one vibration mode. So if I were to click on this button, I can cycle through them, or I can just type in, let's say, 35, and open up a new vibration mode tab, and as you can see here, it says mode 35, and this one is the first one that I open. You can also save it if you want to, although this shouldn't be a .out, this should be a .txt. Okay, so that's another thing I have to fix. Also, another thing that I didn't mention, this tab view right here is custom made, so it's not a WPF tab control, because a WPF tab control, when it runs out of space horizontally, it stacks the tab headers and makes a uniform grid out of them. But this one, the one that I made, so if I were to open a bunch of tabs, this one actually shrinks them like Chrome tabs. Okay, so I'm going to close all this because we don't need them. Actually, this would be faster. Okay, so below that, as I said, we have another 3D viewer, and I mentioned earlier that the previous viewer we opened through an optimization job, so we didn't have this animation expander available, but this one is open through a frequency job, so we can play animation for the molecule. And you can see it vibrates depending on what mode you have selected, and you can cycle through them and it will update in real time. So let's go, let's say 48, and this is what the 48th vibration mode looks like. Or if I were to type in 400, it doesn't go past the limit of 60. We also have, actually let's go to the 60th mode. We also have this animation speed slider. If it goes either too fast and you want to see it at a slower pace, or it goes too slow and you want to see it at a higher pace, you can change the speed between 0 and 2. This is just a multiplier. And in this viewer you can also do the same selecting as in the previous one. And I mentioned you can change the background color, and that is because I have implemented themes. So we have 4 themes: light, colorful light, which is just light with blue highlights. So right now, hovering over these items, you can see the background color is sort of a grayish, and if I were to change it to colorful, it's a sort of cyan color. And it's the same for dark and colorful dark. So you can change the background because if you're in a light theme, this might be hard to see for some people, and you can change the background color to see better. It's just a nifty little thing that you can do. Okay, so I'm going to change it back to dark so I don't burn your eyes. And next in the list we have a TD job. We also have NMR, which is not implemented yet. The inspector is empty. So this will be the last thing I show you. Also, I didn't mention, you can either remove a job by clicking the selected one by clicking on this button, or you can do that by clicking on this little icon right here. So going to a TD job, we have the standard content and save content, and then we have an energy tab which just shows you all the excited states which are in this selected job. And we also have UV visible spectrum, and this should be a graph, but I haven't gotten around to implementing the axis and data intervals yet. So at the moment, when you scale the view, the graph updates. So at the moment, what you can do is just change the smoothing factor, and if I were to go from 1 to a 10, it smooths all the peaks in the graph. And I can go 10, or I can go 100 or 1000 if I want it to be extreme, or I can go 0.0001 and I have really narrow peaks. This graph is drawn using a Laplacian smoothing function. And there you have it. This is all I have to show you for now. Thanks for watching.